Hello friends, welcome back to Graph Theory Lectures. This is our lecture number 3 and in this lecture we are going to discuss what are paths and second what are cycles. Okay, so let's begin with the definition of path. So what is a path? Basically, path is a simple graph in which vertices are in the form of sequence such that two vertices are adjacent if and only if they are consecutive in the sequence. Okay, so let me explain this. What is a path? Let G be simple graph such that vertices of G are in the form of sequence like 1, 2, 3 up to so on n, and edges are in the form L comma L plus 1 where L belongs to 1 to n minus 1. Okay, so these are not tuples, these are set. Yeah. So I will give you an example of path, but first let's understand what is this statement saying. Here we are having edges as L comma L plus 1. That means the two vertices are adjacent if and only if they are consecutive in the sequence. Okay. So first of all, what do we mean by adjacent vertices? So adjacent vertices. The adjacent vertices are those vertices which share an edge. Okay. Let's take an example. Suppose this is our graph. Okay, 1 2 3 4 5. So the set of vertices is 1 2 3 4 and 5. Okay, so the vertex 1 and 2 are adjacent. Why? Because they are sharing an edge. Okay, similarly 2 and 3 are adjacent, similarly 4 and 5 are adjacent, similarly 1 and 5 are adjacent to each other. Okay, so these are adjacent vertices. Okay, so now let's move on to path. What is a path? So here we are saying that two vertices are adjacent if and only if they are consecutive in the sequence. Okay, so let's name this 1 2 3 4 5. Suppose these are the vertices. Now this is these we are connecting to each other, and this is called a path. Okay, this is a path. Example of path. Okay, so I will give you another example of a path in a graph. Let's take this to be a graph. Okay, let's name the vertices 1 2 3 4 5 6. Okay, so here if we will take 1 2 5 and 3 set of vertices, then this is a path. Okay, so you can see here from here that this is a path from 1 to 2, 2 to 5, 5 to 3. Okay, so this is our path. Now one important thing, the important thing is you cannot repeat any vertex during a path. Okay, so like if you will take here 1 2, change the color. If you will take here 1 2 5 2 and 4, then this is not a path. Why? Because 5 and 2 are repeating, so you cannot repeat any vertex, okay, in a path. Okay, so that's all about path. And what is a cycle? As by name you can understand what's a cycle. A cycle is a simple path cycle is a path in which starting and end points are connected, in which starting and end points are connected, or you can say these points are same. Okay, so here how will we define the vertex? Same as n. And how will we define edges? Just l comma l plus 1, where l belongs to 1 2 to n minus 1 union n comma 1. Okay, so let's give an example of cycle. This is a 1 2 3 going so on till n. These are connected with each other, and here these two are also connected. So this is cycle. Okay, let's see another example of cycle. So 1 2 3 4 5. So what is a cycle here? If we will see the 1 4 and 5 is a cycle, right? Why? Because if we will take a path from 1 to 4, 4 to 5, and 5 to 1, actually we have to write 1 here. So now this is a cycle, name it as C. So this is a cycle. Okay, one cycle. Another cycle here is C2, which is 1 2 3 4 and 1. So here you can see this is also a cycle. This one is a cycle. Why? Because its starting and end points are same, and first of all it's a path. Okay, why? Because any two adjacent vertices are consecutive in the sequence, right? Or you can say that any two consecutive vertices in the sequence contains an edge. So this is a cycle. So thank you for watching this video.